All right, let's jump right in. One of the biggest questions I hear all the time is, how do you actually build an AI that's not just a generic chatbot, but something that knows your stuff? Today, we're going to break down exactly how that's done. So let's frame the problem. You've got your company's entire internal knowledge base, maybe a giant PDF of a textbook you need to master, or even just years of your own personal notes. How in the world do you build an AI that's an expert specifically on that private information, and not just the entire internet?
Okay, to build our custom AI, we have to start with the most critical piece, the brain. This is the part that does all the heavy lifting, the actual thinking. And in the world of AI, that role is played by a large language model, or what we call an LLM. So what is an LLM really? Well, you can think of it as the engine at the very heart of our whole operation. It's this gigantic neural network that's been trained on just an unbelievable amount of text. We're talking books, articles, huge chunks of the internet. All that training gives it this incredible ability to understand language, to reason, and to generate completely new, human-sounding text when you give it a prompt.
So, right off the bat, you've got a big choice to make. How do you want to access this brain? On one hand, you can use a super powerful, ready-to-go model like GPT-4 through a paid API. It's easy, it's convenient, and you get the absolute state-of-the-art. On the other hand, you could grab an open-source model like Llama 2 and host it yourself. Now, this route gives you way more control, more privacy, and, down the line, it could even be cheaper.
And I really can't stress this enough, the scale we're talking about here is just mind-boggling. These aren't just big computer programs, they're monumental. They literally have billions of parameters. Those are all the little knobs and dials the model tunes internally to make its predictions. That immense, massive scale is exactly what makes them so incredibly smart.
But, and this is a big but, a standalone LLM has a couple of major weaknesses. First, its knowledge is totally static. It's basically frozen at the moment its training finished. So a model might not know anything that happened after, say, September 2021. And second, it has absolutely no way of accessing your private data or any live information from the internet. It's stuck in a box.
So, we have this incredible brain, but it's stuck in a box, and its knowledge is out of date. How do we connect it to the real world, and more importantly, to our private data? Well, we need to give it a toolkit.
And this is where something called LangChain enters the picture. The best way to think about it is as the central nervous system for our AI. It's a framework that does all the plumbing, all the orchestration. It's the glue that connects our LLM brain to all the other pieces we're about to plug in. It literally makes everything work together.
LangChain is powerful because it's so flexible. For starters, it can create a simple chain that just passes your questions straight to the LLM. But the real magic, the absolute game changer, is when you use it to create agents. An agent gives the LLM superpowers. It can give it tools, like the ability to use a Google Search API to look up live, real-time information before it even tries to answer your question.
Okay, so we've got the brain and we've got the toolkit. That solves the live data problem, which is awesome. But hang on, what about our original mission? How do we make this AI an expert on our own documents? To do that, we need to give our AI a specialized long-term memory. And we do this using a powerful architecture called Retrieval Augmented Generation, or RAG. Now don't worry about the fancy name. The concept is actually really simple. We give the AI its own personal library that it can search, or retrieve from, before it generates an answer.
You see, an AI model doesn't understand words and sentences like you and I do. It speaks math. So we have to translate our text into its language. This process is called embedding. You can think of an embedding as a unique numerical fingerprint of a piece of text meaning. It's all captured in a long list of numbers called a vector.
So now you have all these numerical fingerprints, maybe millions of them. Where do you put them all? Well, you can't just toss them into a normal database. For this, you need a vector database. Specialized databases like Pinecone or ChromaDB are built to do one thing and do it incredibly well. Store these vectors, and then find the ones that are most similar to your question. So here's the four-step game plan for building our AI's memory. First, we load our document. Let's say it's that research paper in a PDF. Second, we have to split it up into smaller, bite-sized chunks.
Third, we run each and every one of those chunks through an embedding model to create its numerical fingerprints. And finally, we load all of those fresh embeddings into our vector database ready to be searched.
All right, this is the moment of truth. We've got the brain, our LLM, we have the toolkit, that's LangChain, and we've built the memory, our vector database. Now let's watch how they all work together in perfect harmony to answer a real question.
This entire flow is that retrieval augmented generation process we just talked about. Let's trace it. So step 1, you ask a question. Instantly, LangChain grabs your question and turns it into a numerical embedding. Then, and this is the retrieval part, it takes that embedding to the vector database and says, find me the chunks of text in our library that are most like this question. The database hands back the most relevant pieces of your document. And here's the augmented generation part. LangChain bundles your original question with that relevant context it just found and sends the whole package to the LLM. The LLM now has everything it needs, your question and the exact snippets from your own documents to give you an intelligent, contextually aware answer.
And that's really it. That is the recipe. To build a modern, custom AI, you just need these 3 core things. A brain, like GPT-4. A toolkit, like LangChain, to connect everything. And a memory, in the form of a vector database to hold all of your special, unique knowledge. And just like that, you've pretty much grasped the fundamental architecture that is powering so many of the custom AI apps you see being built today. It's not magic. It's this powerful, flexible, and surprisingly understandable combination of components.
The amazing thing is, these tools aren't locked away in some tech giant's secret lab anymore. They're accessible to everyone, to developers, to creators, to you. The technology is here. The blueprint is clear. So the only real question left is, what are you going to build with it?